Imagine you are falling, not like tripping on a sidewalk, not like a bad dream where you jolt awake. I mean asterisk falling, through clouds the size of continents, through winds that move faster than the speed of sound, through a sky that never ends, on a planet so enormous it could swallow Earth 1,100 times and still have room. You look around, it's almost beautiful, and then you realize you are never ever going to stop. From space, Jupiter looks like a painting. Those swirling bands of orange, cream, and red, they look like something an artist made. Something delicate, something you'd hang on a wall. The great red spot, that massive rust-colored swirl near its equator, has been spinning for over 300 years. 300 years. Longer than the United States has existed. Longer than most countries on Earth. When the Voyager probes flew past Jupiter in 1979, scientists genuinely gasped. The images looked surreal, ethereal, like a living, breathing piece of cosmic art drifting silently through the dark. But here's the problem. Nothing about Jupiter is what it looks like from a distance. That painting, it's made of poison gas and eternal violence. Those soft, creamy bands, they are jet streams of ammonia and hydrogen sulfide screaming at 500 miles per hour. And that gorgeous red storm you've seen in every astronomy textbook since you were a child. It is a hurricane 3 times the size of Earth that has never once stopped. Not for a day, not for an hour, not for a single second in 3 centuries, and you are falling straight into it. Let's start simple. Let's start with just asterisk breathing. Jupiter has no oxygen, not a trace. What it does have is an atmosphere made almost entirely of hydrogen and helium, laced with clouds of ammonia ice, ammonium hydrosulfide, and water vapor so deep beneath the cloud tops that by the time you reached it, you would already be dead several times over. The moment you enter Jupiter's atmosphere, without a suit, without a ship, just you inhale something that is not air. It burns. The ammonia crystals in the upper cloud layers would shred your lungs like broken glass dissolving in acid. Your eyes would seal shut. Your skin would react like it was being dipped in industrial bleach. You'd be dead in under 60 seconds, but let's say you have a suit. The most advanced suit ever built. A ship, even. A probe. Something tough. It doesn't matter. In 1995, NASA sent the Galileo probe into Jupiter's atmosphere. This was not a cheap piece of equipment. It was a sophisticated machine built specifically to survive the descent. Scientists watched. The world waited. The probe lasted 58 minutes. 58 minutes before the pressure crushed it into silence forever. And here's what makes that terrifying. It never even came close to reaching the bottom. Because Jupiter doesn't really have a bottom. Not the way you're imagining. There's no ground to hit, no surface to land on. Just atmosphere that gets denser and hotter and heavier and more violent the deeper you go, until the very concept of gas stops making sense. At a certain depth, the hydrogen stops being a gas and becomes something that doesn't exist anywhere else on Earth. It becomes a liquid. And then, deeper still, it becomes something called metallic hydrogen. A state of matter so extreme that the hydrogen atoms are compressed until they lose their electrons entirely and start conducting electricity like metal. You are not falling through a sky. You are falling into the interior of a star that never quite ignited, and the pressure increases every single second you descend. We're not talking about the pressure of diving deep in the ocean, though that alone would kill an unprotected human in seconds. We're talking about pressures so extreme that at the cloud base alone, the atmospheric pressure is already 10 times what it is at the bottom of Earth's deepest ocean trench. By the time you reach where the Galileo probe died, the pressure is roughly 22 times that. It wouldn't crush you slowly. There would be no dramatic scene of a ship crumpling inward. The compression would be almost instantaneous. You would stop existing in any recognizable form before your brain had time to register that something was wrong. But it gets worse. Jupiter's storms are not like Earth's storms. On Earth, a hurricane is terrifying. We evacuate cities, We board up windows. We treat it like a catastrophic event. Jupiter's storms would treat a Category 5 hurricane the way a Category 5 hurricane treats a light breeze. The jet streams on Jupiter travel at 400 to 500 miles per hour. Sustained, permanent, endless. The bands of color you see from space, those are rivers of wind running in opposite directions, and where they meet, they create something vicious. Sheer zones of turbulence so violent that any structure trying to pass through them would be torn apart at the molecular level. The Great Red Spot alone generates wind speeds at its edges of about 400 kilometers per hour, and it pulls in surrounding material like a slow, eternal drain in the sky. Spacecraft trajectory models have to account for its gravitational pull on anything that gets near it. It is not just a storm. It is an asterisk permanent feature of the planet. It is more stable than most mountains on Earth, and it is shrinking. Scientists have been watching it for decades, and the red spot has been slowly getting smaller, which means whatever energy is driving it is becoming more concentrated, more intense, not less. You wouldn't just be torn apart in those winds. You'd be spun, stretched, and distributed across a region of atmosphere larger than an entire continent before you had time to feel it. Here's something most people don't think about when they picture Jupiter: the radiation. Jupiter has the most powerful magnetosphere of any planet in the solar system, roughly 20,000 times stronger than Earth's magnetic field. And unlike Earth's magnetic field, which shields us from solar radiation, Jupiter's magnetosphere is itself a death trap. It traps high-energy particles from the Sun and from Jupiter's volcanic moon Io, and accelerates them into belts of radiation so intense they can damage spacecraft electronics within hours. The Juno spacecraft, one of the toughest robotic probes NASA has ever built, with a radiation-hardened vault protecting its most sensitive instruments, still absorbs the equivalent of over 100 million dental X-rays over the course of its mission. The engineers planned for this. They knew the radiation would eventually kill the probe. For an unshielded human being, the radiation around Jupiter would deliver a lethal dose in less than a day in even the outer regions of the radiation belt. Closer in, near where you'd be falling, the dose rate climbs so high that the numbers become almost meaningless. You would not get sick. You would not develop cancer over years. Your cellular structure would begin failing almost immediately. Your DNA would be rewritten into something that can no longer function. And this is where things change, because we haven't even talked about what's happening asterisk inside Jupiter yet. Nobody knows exactly what's at Jupiter's core. We have models. We have theories. The leading hypothesis is that there's a dense, rocky or metallic core surrounded by tens of thousands of kilometers of metallic hydrogen, that electrically conducting fluid we talked about earlier, which is what generates the planet's monstrous magnetic field. But recent data from the Juno mission suggested something that rattled scientists. The core might not be the solid, compact thing we imagined. It might be asterisk fuzzy, diluted, dissolved, as if something ancient and violent, perhaps a collision with a massive protoplanet early in the solar system's history, smashed the original core apart and spread it outward through the interior in a diffuse cloud of dense material. Jupiter may have swallowed something enormous early in its life and never fully digested it. This means that at the very center of this planet, under millions of atmospheres of pressure, under temperatures hotter than the surface of the Sun, there is something we don't fully understand, something behaving in ways our physics barely has language for. You would never reach it. Nothing we've ever built has come close, but it's there, pressing outward, quietly generating a magnetic field that stretches past Saturn, quietly reshaping the orbits of asteroids and comets with its gravity, quietly reminding the solar system that it is, and always has been, in charge. Here is what Jupiter actually is, when you strip away the mythology and the textbook diagrams and the pretty photographs. It is a failed star, A world so massive it almost became something else, something that burned, something that shone, and instead it just sits there, patient, enormous, the largest object in the solar system outside the sun itself. Its gravity has been pulling in asteroids and comets for 4.5 billion years, acting as a shield for the inner planets. Some scientists believe Earth's existence, your existence, is only possible because Jupiter spent billions of years taking hits meant for us. And what does Jupiter ask for in return? Nothing. It doesn't know you exist. It has no surface to stand on, no sky you could breathe under, no space inside it where life, as we define it, could find even a single foothold. It is not hostile to you. It is something far more unsettling than hostile. It is asterisk indifferent. The universe made Jupiter before it made anything like you. It made pressure and radiation and eternal storms and metallic seas and cores of unknown matter. And it made all of that long before it ever got around to making something small enough to be afraid of it. We look up at Jupiter and we call it beautiful, because beauty is the only word we have for things our minds can't contain. But beauty is just the face that terror wears when it's too big to look directly at. The universe was not built for us. It was built first, and we arrived late, clinging to a small, warm rock at the edge of everything, staring out at a solar system that would erase us without a moment's hesitation. Jupiter is just the most honest reminder of that fact, and it's been there, swirling, raging, silent, patient, for longer than the word asterisk danger has existed. Subscribe. You are small. Stay curious.